Good day, ladies and gentlemen. This is Banners Online Maths. Today, let's see what we have on the board. Okay, the question says the function f is defined by the whole of this. That this function f is defined by this function 3x plus 4 all upon x minus 3. In fact, this simply means all real numbers minus the set of 3. That's the domain of this function. This is representing the domain of the given function. Simply means all real numbers except the set of 3, except 3, which simply means that any number you replace x to be will make this function to exist, except when you say x is equals to 3. So if x is equals to 3 here, this function will not exist. So this is just telling us the domain of this function. Okay, we're asked to show that the function f is bijective. We're asked to show that the function f is bijective. Solution. Given the function f, which is f of x, to be equals to this function, which is 3x plus 4 all upon x minus 3. That's the function. We are asked to show that this function is bijective. You must know that for a function to be bijective, that function must be one-to-one and onto. So once a function is one-to-one or injective, and it is also onto or surjective, once these two conditions are satisfied, we now conclude that the given function f of x is bijective. I repeat, for this function to be bijective, because we are asked to show that f, which is this function, is bijective, which means it must be surjective and also injective. So if it is injective, it is one-to-one. It must also be surjective, that is onto. Of course, it's mapping. Okay, now let's show that this function is injective. For injective, in brackets 1, 2, 1. What will happen? Our f of x must be equals to f of y. That f of x must be equals to f of y. And what does this mean? This simply implies that x must be equals to y. So if this condition is satisfied, we'll now say that f is injective. Okay, let's clean the board. Given that f of x is equals to 3x plus 4 all upon x minus 3. Now we are trying to show that f is injective, and what is the condition for injective? That f of x must be equal to f of y. And here f of x has been given. We need to find f of y. For f of y, we're going to have this to be, for f of y is going to be, now let's compare something. Coming here, what do we see before the bracket? It is f. And what do we have before the bracket? It is also f, which signifies same functions. Since they are same functions, we can now compare whatever they have inside the bracket. What do we have inside this bracket? X. And what do we have inside this bracket? Y. This simply means that x is now equals to y. As a matter of fact, here, wherever you see x, you replace it to be y. If we do that, we're going to have this to be, we have 3, instead of 3x, x becomes y plus 4. All upon, instead of x, we have y minus 3. Now, we have gotten f of y. Remember, f of x was given. For this to be injective, f of x must be equals to f of y. Okay, let me clean. For injective, our f of x must be equals to f of y. Okay, let's still clean further. Now, do we know f of x? F of x has already been given, which is f of x is said to be 3x plus 4 all upon x minus 3. This equal to is this. Do we have f of y? Yes, f of y is this, which is 3y plus 4 all upon y minus 3. Now we are going to simplify this. How do we simplify this? We are going to cross multiply. Cross multiplying, if we cross multiply, we're going to have this to be, of course, we have 3x plus 4 all upon x minus 3. X minus 3. Which is equals to 3y plus 4. 3y plus 4 all upon y minus 3. Y minus 3. If we cross multiply, you find out that this will multiply that, y this will multiply that. If we do that, we're going to have this multiplying that will give us 3x plus 4 multiplied by y minus 3, which is equals to this multiplying that will give us 3 minus, that's x minus 3 multiplying that of 3y plus 4. Having done this, the next is to open the brackets. Of course, let's expand this. For us to expand this, what is the first term here? The first term here is 3x, which will multiply the whole of this, which is y minus 3. Then followed by the second term here, which is plus 4, which will also multiply the whole of this, which is y minus 3. So that is all in the left hand side. Coming to the right hand side, which is equals to, we do the same thing. The first term here is x, which will multiply the whole of this, which is 3y plus 4. Then followed by the next term here, which is minus 3. Minus 3 will also multiply the whole of this, which is 3y plus 4. Okay, let's open the bracket. If we open the bracket here, you find out that this 3x outside the bracket will multiply the two terms inside the bracket here. If this happens, we are going to have this to be 3 times y, 3x times y will give us 3xy. Okay, then 3x times minus 3 will give us minus 9x. That's for that. Now coming here, the 4 outside the bracket to multiply the 2 terms inside this bracket. If that happens, we are going to have plus 4 times y will give us plus 4y. Then plus 4 times 3 minus 3 will give us minus 12. That is all in the left hand side. Coming to the right hand side, we do the same thing. This x outside the bracket will multiply the 2 terms inside the bracket. If we do that, we are going to have x times 3y will give us 3xy. Then plus x times 4 will give us 4x. That's for that. Then coming here, minus 3 outside the bracket will also multiply the 2 terms inside this bracket. If we do that, this is going to be minus 3 times 3y will give us minus 9y. Again, minus 3 times 4 will give us minus 12. Now let's see if there are things to tackle. You found out that 3xy in the left hand side will cancel 3xy in the right hand side. So this in the left hand side will cancel that over there. Now we found out that also minus 12 in the left hand side will also cancel minus 12 in the right hand side. So this will cancel that. What left now becomes minus 9x plus 4y in the left hand side. Now what left in the right hand side simply becomes 4x minus 9y. So what are we going to do? Let's collect like terms. Let's collect like terms, which means everything about x, all the terms that contain x, one side of the equality sign, and those terms that do not contain x move to the other side of the equality sign. So I already have minus 9x. Now coming here, this is plus 4x. Crossing over becomes minus 4x, which is equals to, now we already have 9y minus 9y already here. Now we now have 4y plus 4y. Crossing equality sign simply becomes minus 4y. If we further simplify, this is going to give us minus 9x minus 4x automatically will give us minus 13x, which is equals to minus 9y minus 4y automatically will give us minus 13y. So we found out that minus 13y in the left hand side will cancel minus 13y in the right hand side. Okay, let me clean the board. Okay, if we don't want to do that, you can as well divide both sides by the coefficient of x. Dividing both sides, dividing both sides by minus 13. That's the coefficient of x. If we do that, we already have minus 13x, which is equals to minus 13y, as we have here. So if we divide the left hand side by minus 13, we also divide the right hand side by minus 13. So if I like that, this minus 13 will cancel this. What left here becomes x, which is equals to this minus 13 will cancel this minus 13. What left here becomes y. So what do you suggest? Since x is equals to y, which simply means that the function f of x is injective. Since x is equals to y, therefore f of x is injective, or 1, 2, 1. Next, we cannot say that this function is bijective since it is injective. For us to conclude that the given function f or f of x is bijective, it must be both injective and surjective. Now, we have found out that we have tested for injective and found out that the function is injective since x is equals to y. The next is for us to check or prove that the same function is also surjective. So if it is surjective, we now draw conclusion that the given function is bijective since it is both injective and surjective. Okay, let's clean up here.